Be stay at home, be safe, and be healthy. A warm welcome to all of you in the lecture on composite materials. Under this title, just we are going to discuss about the definition of about the composite material and what are the different types of the composite materials, their properties, how they are processed, and finally we are going to conclude this lecture session with the applications of composite materials. Today, we see many products which are in the market. Talk about smartphones, intelligent phones, smart materials, and so many new things come. Polymer matrix composites are present in almost all aspects of modern life, from gadget components to a vast selection of automotive accessories. Composites consist of the combination of two or more materials. That is, the composite is defined with the help of the matrix and fiber. The composites may possess a property of very strong and stiff. Several times it will be very much greater than that of the steel or aluminum. And also it have fatigue properties which are generally better for common than common engineering materials. Toughness is often greater to composites and can be designed that do not corrode like steel. So they have a high corrosion resistance property also. So that the composition of the composite is defined as the composite is composed with the help of the fiber or filament called as a reinforcement materials with matrix. Finally, it gives a composite material. The fiber or filament is going to possess high strength, high stiffness, and low density, whereas the matrix is having its properties as good shearing property and low density. The mixing up of these two will produce a new product called as a composite by having the high strength, high stiffness, good shear properties with low density. In broad sense, if you want to define the term the composite materials as the solid materials which is composed of more than one component, where in those components are in separate phases. For example, let us take two materials A and B. Let we mix these two by means of applying pressure, temperature with respect to time, where we can get a product of C. This product will always be synergy. That is, it will try to take the advantages of A and advantages of B and try to give a new product that has a required property. If we try to take the cross section of the composite materials, we can still distinguish what is the component A added and what is the component B added. So this is a definition for composite. I hope you may understand now what is meant by composites, in which the component A is called as a matrix and component B is called as a reinforcement. So from this slide we can understand that the reinforcement possesses property of the high strength, high stiffness, low density, and matrix possesses the property of the good shearing and low density, where the mixing of this A plus B gives you the C composite, which have the properties of both high strength, high stiffness, good shear properties, and low density. Before getting into the types of the composite materials, the polymers that are often used as a composites are either thermoplastic polymers, thermosetting polymers, or elastomers. They are the source of wide variety of low-priced raw materials which offer many advantages like low specific weight, high corrosion resistant, good electrical and thermal insulation, attractive optical properties, and so on. What is a polymer matrix composites? The polymer matrix composite is defined as, before that, let us discuss about the types of composite materials. There are two different types of the composite materials are available. One is called as a natural composites, which may exist in nature, and the second one is called as a synthetic composites, which is a man-made. The natural composites, the best example is wood, where it consists the matrix as a lignin and fiber as a hemicellulose, which acts as a reinforcement materials. And the classification of the synthetic composite materials, which was done in three different ways. One based upon the ceramic, and the another one is on metal, the third one is on polymer. The polymer based, polymer matrix composites, the metal matrix composites, if it is ceramic matrix composites. Now we discuss about what is meant by polymer matrix composites. It is defined as a material made up of fibers that are embedded in organic polymer matrix. These fibers are introduced thus to enhance the selected properties of the materials. The classification of PMC, that is a polymer matrix composites, which is kept classified on the basic level of the strength and stiffness into two types. One is reinforced plastics, which is conferred additional strength by adding embedded fibrous matter into plastics. And second one is the advanced composites. It consists of the fiber and matrix combinations. Regarding the properties of the polymer matrix composites, there are two major components. One is said to be as a matrix, another one is a reinforcement. The matrix, it is a polymer which is a continuous phase and is classified as the weak link in a polymer matrix composite structure. Example, polyethylene, nylon, polystyrene, polypropylene, polyvinyl chloride, epoxy, polyesters, etc. And the second component is the reinforcement. This is a discontinuous phase and is a principal load bearing component. It can be either glass or quartz or carbon fiber. And there is a third component which is called here as the interface. The interface between the reinforcement between reinforcement and matrix phases, where the transmission of the load takes place. And then is the processing of polymer. Normally, there is a difference between the composite and alloy. In alloy, when we mix the material A with B, it gives a product of C, which will have a better property as the customer required, but when we try to get a cross section, we will not be individually able to detect the presence of the material A and B. This is the main difference between alloys and composites. Okay, now we discuss the processing of the polymer matrix composites. This slide shows you the other qualities that come with the reinforcement of polymer materials. Apart from the types of the matrix and reinforcement used, other factors that affect the properties of the polymer matrix composites are the relative proportions, geometry of reinforcement materials, nature of the interface. Now this slide shows you the other qualities that comes with the reinforcement of the polymers: improved processing, density control, and then controlled thermal conductivity, thermal expansion control, flame retardancy, low cost, greater toughness, impact resistance, fatigue resistance, fracture resistance, abrasion resistance, corrosion resistance, high specific strength to weight ratio, and also having the high specific stiffness to weight ratio, where the fatigue strength is kept improved and also possess very high creep resistance. This is the processing of the polymer matrix composites. Polymers are reinforced with fibers which are 8 to 12 micrometer in diameter, either as continuous single or chopped. Multifilaments that are woven into a cloth and other types of performed textiles. These fibers are then impregnated into the matrix polymer in liquid form by means of injection, extrusion, and pressing, and then it is kept cured to the final composites. Regarding the advantages of using these polymer matrix composites, it may possess the tailor-made property. Just to give you an example, suppose if you want to get a shirt stitched according to our size, what the procedure that we have to follow? We have to go to the cloth merchant, buy a piece of cloth, and then go to the tailor and tell him to stitch a shirt according to our dimension or measurements. Similarly, in the context of composites, we have to choose a particular material for the application and hence to design the composite materials to bear the particular load, designing of materials depending upon the applications, and so on. And the second main advantage is the low weight. Strength to weight ratio and stiffness to weight ratio is better with composites as compared to the other conventional engineering materials. Based on this, it can be used in more in aerospace applications. The third one is the good mechanical properties. The fatigue properties, toughness, strength to weight ratio comes under the mechanical properties. They are better in composites compared to the conventional engineering materials. The fourth one is the corrosion resistance. In some underwater applications, there is a corroding environment where the materials to be high corrosion resistance. Composite materials satisfies it. And finally, the ease of fabrication and installation. In some cases, for example, the whole bridge is constructed in overnight. How it is possible? It has been possible because all the beams and columns or the structural members of the bridge were not made or assembled or not fabricated in the site itself. They were done at some other places, taken to the site and assembled there in a minimum possible time, which shows the ease of fabrication and installation. Okay, finally, we are going to see about some applications of the polymer matrix composite, where it is used in the transportation. For example, it is used in train, car and buses, where most of the parts are replaced by material matrix composites. And the composite materials, because of its light, stiffer and perform very much higher. In the space shuttles, yes, very high temperature, very high strength, there is a composite, ceramic matrix composites are coming up in a big way. In defense applications, today we are talking about the bulletproof jackets, bulletproof helmets and so on. Earlier, the weight which was talked about was of about 15 kilos, 21 kilos. But now, they were reduced to 3 kilos and 5 kilos, which gives a soldier a big boon to wear it and use it during the operation. In sports, the cycles becomes very light. The cycle today are made of carbon fiber composites, which they can claim to be around 3 kilos. Similarly, sports peoples wearing the t-shirts, which is coated with the nanomaterials, which performs very well and does not give any odor smell. And there are shoes made of composite materials, which are predominantly elastomer composites, polymer matrix composites. And the blade in the windmills are also made out of polymers and matrix composites. If you take the commercial aeroplanes, there is of about 50% of the material is made out of the composites because of their high strength to density, stiffness to density. Today, houses are made out of composite materials, and these houses are first it came into existence for disaster management. The complete roof and the side panels are made out of the polymer matrix composites, which has acoustic proof also. In addition to these applications, the polymer matrix composites are playing a vital role in the field of the marine, medical applications to be act as a work table as shown in the diagram, and also in the industries they were used as an industrial spring and so on. For example, the Boeing 787 Dreamliner composite structure is listed here. The components that are used as a composite structure are almost full fuselage, upper and lower wing skin, radome, wing flaps, elevators, ailerons, vertical fin and horizontal stabilizers, all are made by using the composite materials, where the use of composite is 80% by volume and 50% by weight. The total materials involved within it in the Boeing 787 Dreamliner is listed here, where the 50% of the materials are only with the help of the composites, and the rest of the 50% is made with some other materials, steel 10%, titanium 10 to 15%, and aluminum 20%. So when compared with the 777 Boeing, here in the 787, 50% of the materials are involved only with the composite materials, which is a very boon to us. Thank you very much for your patient listening.